So chemistry alternative to practical revision. This is the second part. As we discussed some questions earlier. In this experiment, a student investigated a rate of a reaction between a nitric acid and an excess of a magnesium carbonate. As you can see, in a small tube, a magnesium carbonate solid is there, or a liquid magnesium. So magnesium carbonate is shown here, and magnesium carbonate is suspended in a conical flask and added with a nitric acid. So it will give off carbon dioxide. So 50 cm cube of a nitric acid in the container, a test tube were released, allowing the magnesium carbonate to mix. And a stopwatch was started in the volume of a gas collected. Inverted measuring cylinder was measured every 10 seconds for 80 seconds. Like measured every 10 seconds for 80 seconds. Then state one possible source of error in this experiment and one improvement. So the source of error related to this experiment in which we are collecting a gas and how we can
use a gas syringe, some gas may dissolve.
yeah, so and even if you see like a measuring cylinder, it's a 250 cm cube measuring 250 cm cube measuring cylinder. Like 250 cm cube is it's a large volume 250 cm cube collecting a 250 cm cube of a gas in a lab. So either we reduce like use a smaller measuring cylinder or we use a gas syringe. So one source of error, we are using a measuring cylinder, a large measuring cylinder is used, or even if you mention use of a measuring cylinder to collect a gas. And how we can improve that, we can use a gas syringe by replace the measuring cylinder with a gas syringe. Then student calculated the total volume of the gas collected in this to be 85. Suggest and explain why actual volume of a gas collected was different from 85. Like student predicted that it should be 85, but he will collect a different volume. What might be a result? What might be a reason for that? For not collecting the same amount?
Some gas dissolved.
Some gas dissolved or a gas is soluble. So the volume of the gas collected will be lower than what the student predicted. Then another experiment, a teacher investigated a rate of a reaction between the two solutions J and K with the sulfuric acid at different temperatures. 4 experiments were carried out. Experiment 1 was a large measuring cylinder was used to pour 50 cm cube of a distilled water and 40 cm cube of a sulfuric acid in 250 cm cube conical flask. A small measuring cylinder was used to add 2 cm cube of a methyl orange and 5 cm cube of solution J into a mixture. The temperature of a mixture was measured. The reaction was started by adding 5 cm cube of K into a conical flask and immediately starting the timer and stir the mixture. The time taken for a mixture to turn pale yellow or the light yellow was measured. The final temperature of a mixture was measured. And then experiment 1 was repeated but the mixture in a conical flask is heated to about 30. And then it is heated to 40, then to 50, like because we are investigating how the temperature affects this reaction. So we are changing a temperature. Suggest and explain the effect on the result using a burette to measure the volume of solution J. Solution J, 5 cm cube of a measuring cylinder was used to add 2 cm cube methyl orange and 5 cm cube of solution J into a conical flask. So we were using a measuring cylinder. Now what they're saying, instead of a measuring cylinder, if we use a burette.
So more accurate volume.
So because yeah, burette is giving a more accurate result. Burette, more accurate volume will be there. So suggest and explain the effect on the result using a burette. So 2 marks are there. How you will score these 2 marks? 1 mark will mention the results will be more accurate.
The reliability of the experiment will increase.
Yeah, reliability of the experiment, like more reliable or more accurate, you can say, as you are using a burette, or burette is more, the result will be more accurate because burette is more accurate compared to that of Beijing cylinder. So results will be more accurate. And the reason is that because the burette is accurate compared to Beijing cylinder. So just explain one other improvement for these experiments. So what actually is happening in this experiment? In this experiment, we are mixing the two substances with each other. And what we want in this one, because see, what we did here, we mixed the two solutions. If you check the beginning of the question, we mix the two solutions and we are investigating how the temperature can affect the rate here. So first it is done with like 30, then it is done with 40, then with 50. So for these type of experiment in which we want to maintain a temperature, so what you can mention here, you can mention use a water bath or use a thermostatically controlled environment in which you can maintain this experiment, like maintain a temperature for the experiment. Is it clear? Or
Yes, sir.
normally, like for such experiment in which you are measuring the substance, like measuring volume or measuring time, you should always repeat the experiment. Adding water to sulfuric acid. Yeah, adding water to sulfuric acid is vigorous, but it's a very small quantity is added. That's why it won't make much difference. Then another experiment is there. A student investigated the reaction between a dilute hydrochloric acid and an aqueous solution of a sodium carbonate. Reaction of water with sulfuric acid is vigorous because it is exothermic reaction. It releases energy. So the water which is formed is turned into a vapor. Like the temperature increase. So that is like first molecule when it is mixed with the water, the reaction give out energy. That energy is absorbed by the neighboring molecule. So it speed up the rate of reaction. That's why it is vigorous. So sodium, a student investigating a reaction between a hydrochloric acid and a solution of a sodium carbonate, which is labeled solution L. Three experiments were done. Experiment one was a measuring cylinder was used to pour 25 cm cube of solution L into a conical flask. 10 drops of thymol pathylene indicator was added. A burette was filled to 0 mark with a hydrochloric acid. Then a hydrochloric acid is added until the solution just change to colorless at the end point. So end point means that when the solution show a color change, we can call that as an end point. So just why universal indicator cannot be used. This is again a common question. I sort out
Well,
some common questions.
because it doesn't have a pH of 7.
No. The idea is that universal indicators show a transition of the color. Like universal indicator does not have an acid, like when you use like example methyl orange or you are using a phenolphthalein or thymol pathylene, they show only one transition. But for if you are using a universal indicator show a transition of the colors. So it will be hard to identify the pH of a solution. Like it has more than color, more than one color changes are there. So it will be hard. Like example, say the solution was acidic, first it will be red, then it turned into orange, then it turned into yellow, then green, then blue, then a violet or purple. So there are a lot of color changes in between the experiment, which will be hard to identify. So the idea is that there will be many color changes occur during the experiment. So it will be difficult to find the endpoint. Is it clear, this one?
Yes, sir.
Then suggest how reliability of a result could be checked. Remember one thing, whenever you want to check the reliability of the result, the best thing is what you do, you repeat the experiment. Like how you are sure, how you will be sure that your results are accurate. So you should always repeat the experiment, compare them, find anomalous, check for the average, like
Until
find an
three
average.
common results.
Yeah, repeat
Three
to
constant
spot.
results.
Yeah, repeat to spot anomalous results as well. That's right. Yeah, that's also a good point. Repeat until you got two concordant results. Like in repeat until your results are concordant means like they're within the range of 0.2. Two of the results. Then one advantage. So it's of 2 mark. 1 mark is for repeat the experiment. One you can mention take average or identify the anomalous results, or you can also mention repeat the experiment until it's like 2 of the values are concordant to 0.2. That also you can mention in a titration experiment. Advantage of using a measuring cylinder. How a measuring cylinder will be an advantage? So it will be fast or quick to transfer. And how this will be a disadvantage?
Sir, I didn't understand that. How would it be quick?
Which one?
Sir, the advantage of measuring cylinder.
Advantage of measuring cylinder, if you want to pour a liquid into another container, a measuring cylinder, you can use a measuring cylinder and transfer it quickly. But if you are using any burette or a pipette, because in a pipette, it takes time to transfer the solution. When a pipette is like 25 cm cube, it takes time to completely empty the pipette as compared to that of a measuring cylinder.
Okay, sir.
Clear?
Okay, sir.
Okay. So this is always the case. This is again a common question, as I sought out some common questions in this. So this is a common question. Even the answers you can find, the answers are there attached as well. Better learn them, as it will be same, like it won't be different. So a chemist heated a solid zinc chloride until it became a molten. An apparatus was then used to pass electricity through a molten zinc chloride using inert electrode. A Bunsen burner was used to heat the zinc chloride. Describe how a Bunsen burner is adjusted to give a very hot flame. Look, if we want to
By
give a very hot,
increasing the concentration of oxygen.
yeah, increasing. So basically, we cannot change the percentage of oxygen, but what we can do, we can allow greater amount of air to mix with the content. As a result, like it will have a complete combustion. So how we can have a complete combustion? So there are air holes are there. Air holes or the collars are there for a Bunsen burner. Even that is like normal stove which you are using. You can reduce or increase the flame intensity by adjusting the air holes, like amount of gas which is coming out from the cylinder, from the pipe. So same thing here. In this case, amount of a gas which is coming out, that we are not changing. The only thing what we did, we open the air holes. As a result, more air or oxygen will mix with the gas and it will cause a complete combustion. So we will open the air hole, or you can also say open the air collars. As a result, greater amount of plenty of oxygen will be available for a complete combustion. Suggest why iron electrode
Sir,
cannot
can
be
we
used.
write that increase the size?
What?
Sir, can we write that increase the size of air hole or something?
Air holes are like actually fixed in size. You cannot change. You just change an amount of in, like these air holes in a Bunsen burner.
Okay, sir.
Okay. So when the gas, the fuel is coming, it is mixed with the air. So as a result, if air holes are open, more oxygen will mix, combine, and a complete combustion give a hot flame. It is shown here at the bottom, the collar, the air hole is there. Page 17. And then suggest why iron electrodes cannot be used the experiment whenever we are doing electrolysis experiment. Why we don't use iron, or why we cannot use iron? Because it's a reactive, yeah, that's right. Because reactive materials cannot be used as electrode. The student investigated a time to collect a 40 cm cube of a hydrogen gas when magnesium react with a sulfuric acid. So here a sulfuric acid and a distilled water is there. Five experiments were done using a measuring cylinder. 8 cm cube of a sulfuric acid was poured into a boiling tube. Using a second measuring cylinder, 12 cm cube of a distilled water was added to a nitric acid in a boiling tube. The apparatus is set up as shown the diagram, ensuring an inverted measuring cylinder of 50 cm cube was there. Then a bung was removed from a boiling tube, and a coil length magnesium ribbon was added. Like we had like here we have a dilute sulfuric acid and a distilled water, and then we add a bung is immediately placed and a timer started, and time taken for 40 cm cube of gas collected was measured, and student felt outside the student felt outside the boiling tube, like heat is there. What would measure it? Why would measuring a volume of a dilute sulfuric acid with a burette rather than measuring cylinder be an improvement? So the same answer here. Why it is an improvement? Because it is more accurate. In a boiling tube, a substance can be boiled, like it can withhold a high temperature. That's why it is refers to a boiling tube. So improve. So the magnesium start to react with a dilute sulfuric acid as soon as added. Why does this decrease the accuracy of the investigation? Like the magnesium start to react the moment we add a magnesium, it will start to react with sulfuric acid. Yeah. What might be the reason? So some of the gas might escape. And describe one improvement that we could make to overcome this problem. So that is, as I mentioned in the beginning, if you remember the previous session, I mentioned the use of a Thistle funnel. Or we can also use a conical flask, and that is having an acid. And we can attach a piece of magnesium is there in a tube, a small tube, a piece of magnesium is placed, and that is connected with a cotton wool or a thread. The moment we remove the thread, the magnesium will combine with sulfuric acid and the gas is given off, which we can collect in the same manner, or using a measuring cylinder can also be measured. Is it clear, this one? No, that's very, we just remove this. It's a very small part is there. Even you just break the thread from, so it will fall. You can use that method. We can suspend the magnesium, even like you just break the, like cut the thread, and then the magnesium will fall and mix with the sulfuric acid and give off the gas. as it reacts
Sir,
with
but
sulfuric acid.
wouldn't the thread like get stuck in the bunk?
Usually space is there. It's not like it's very rigid. It's a normally a rubber bung is there, so it's easy to like even a friction. It's not a very hard you say a wooden. It's normally a rubber bung is there, so even though friction is there, but when we try to pull out the thread, it can easily come out. Or you can also use a method, a Thistell funnel, which I mentioned in the beginning. Then a student investigate the reaction between the aqueous potassium hydroxide with two solutions of a hydrochloric acid. Burette was filled with solution A, then some of a solution was run out from so that a level to the scale. A measuring cylinder, 25 cm cube of potassium hydroxide. Then potassium hydroxide was poured into a conical flask. Methyl orange was added, and then the solution was slowly added until indicators show a color change. Until indicators show a color change. Then a conical flask was emptied and rinsed with the distilled water. And then a burette was emptied and rinsed with distilled water. Then a burette was rinsed with solution B. So, and then the experiment is done in the same manner. Before starting the titration experiment, the conical flask was rinsed with water. Why the conical flask is rinsed with water? So same question. Why a conical flask is rinsed with water? To remove the residue from previous experiment. And the conical flask was not then rinsed with aqueous potassium hydroxide. State how rinsing the conical flask. So if you remember, we did the similar experiment. So when conical flask is there, just rinse the conical flask with water and that is enough. Even trace of water are there, that is enough. We don't add conical flask with the substance which we want to fill. Like in the question, 25 cm cube of potassium hydroxide is added to a conical flask. Even water is there in this, it won't make difference. But if we rinse this conical flask with potassium hydroxide, then there will be trace of potassium hydroxide in the conical flask. And then this potassium hydroxide, like some potassium hydroxide is still there. Maybe 2 cm cube of potassium hydroxide is there after rinsing with potassium hydroxide. And then we pour 25 cm cube of potassium hydroxide. So the total volume of the potassium hydroxide in the conical flask won't be 25, it will be more than 25. That's why whenever we rinse the conical flask, we only rinse with water. So they state how rinsing a conical flask with potassium hydroxide would change the amount of solution B. So solution B, what we need? We need more solution B because we need more of a solution B. Why we need more of solution B? Because here 25 cm cube of potassium hydroxide and 2 cm cube of potassium. So total volume of a potassium hydroxide now in a conical flask will be 27. So 7 cm cube of potassium hydroxide need more volume of B as compared to 25. So remember one thing, in a titration experiment, conical flask you should never rinse a conical flask with a chemical. It's always with water. But for a burette, when you fill the burette, like example, you fill the burette with hydrochloric acid, you rinse with water, then you should again rinse with the hydrochloric acid to remove any trace of water. Is it clear? Here, why the concentration increased? Because we are not adding water, we are adding potassium hydroxide. So means the more of the potassium hydroxide will be there, more particles of a potassium hydroxide in the flask now, and we add 25 cm cube. That's why the concentration increased. concentration is changing because we are adding the potassium hydroxide. After rinsing with potassium hydroxide, already some potassium hydroxide in the flask, and you fill it with further 25 cm3. So 27 cm3 will have more particles of potassium hydroxide. Describe one change that could make to the apparatus to improve the accuracy of the result. So if you want to improve the accuracy of the result, what we actually do, we should always use, like example, here we are using measuring cylinder, so we should use a pipette. Use pipette to measure the volume of solution as compared to that of measuring cylinder. Describe what effect using a large conical flask have on the result. If you use a large conical flask or a small conical flask, it won't make difference to the titration experiments. So there will be no effect. Even if they say what will be the effect on the result if an experiment is done at high temperature. So it won't, because temperature will affect rate, but not the amount of the reagents or the chemicals needed. So it will be no effect on the amount of the reactant. Rate will be affected, but not on the amount of the reactant. Then what would be the effect on the result if any of the solution was warm before adding a hydrochloric acid? And effect on the result, and reason is that. So will there effect? There will be no effect because there is no change in amount of the reactant, or we are using the same amount of reactant. We are using the same concentration or same amount of the reactant. That's why there is no effect on the results. Is it clear, this part?
Yes, sir.
Okay. Then student investigating a reaction of a sodium thiosulfate with solution of potassium iodide, and solution C and D are there. A burette. So burette was filled with an aqueous sodium thiosulfate, and using a measuring cylinder, 20 cm3 was solution C was poured, and 10 cm3 of a sulfuric acid and 1 gram of potassium iodide was there. Then we repeat the experiment. Conical flask was emptied, rinsed with distilled water. Then experiment 1 was repeated using solution D instead of solution C. Two sources of error in such experiment. So what are the sources of error in this experiment? Like we are using a measuring cylinder, or in this color change experiment, we might overshoot the end point, or we added too much quantity of a solution from the burette. So what we should do, we should use a pipette, or we should use a burette and slowly add. Yeah, difficult to identify the color change, so overshoot. So the things you should write related to the apparatus, you can mention the apparatus, like use of a measuring cylinder. You can mention experiment is not repeated, because in this one we should always repeat the experiment when we are measuring the volume, and we are going past the endpoint. And how we can improve? We use a pipette or a burette, repeat the experiment, and add small quantity, like slowly adding the content from the burette. So two sources of errors and two improvements for these titration experiment. I mentioned 3 of them. One is apparatus, one is a technique you're using, like not repeating it, and one is related to the endpoint. Then experiment investigating a rate of reaction between hydrochloric acid and sodium thiosulfate. So it will form a solid precipitate of a sulfur will be there, and we are measuring a time for this cross to disappear, or the text to disappear. Suggest the effect on the result using 100 cm cube. So 100 cm cube conical flask will have a, because like 100 cm cube conical flask will have a smaller base. So when it will have a smaller base, the depth of the solution will be more. If the depth of the solution is, because same amount of solution, but different imaging cylinders, so this depth of a solution is more. As a result, when the solid will form, the solid will appear that it disappear quickly as compared to, printed words, or the text will disappear fast. And what is the reason for that? Because there is a greater depth of the solution. So solution is having a greater depth. That's why, because here the solid will form it, but it is more spread out. So small thickness, like thickness is less. But here the thickness of the PPT, the precipitate, will be more. So the cross will appear to like disappear quickly. Then the diagram shows an apparatus used to prepare a sample of a chlorine gas, which is more dense. Then use a diagram, identify two mistakes. Look, they already give you the answer. They mentioned chlorine is more dense. But how we are collecting in the manner of like low dense than air gases. So the method of collecting a gas is not correct because chlorine is dense, so it will sink. Then what is the other error related to the experiment? The mistake?
Say the jar is in. No.
Yeah, that is one. What else? If you check even you check this one, this conical flask, this flask is open. So it won't make the second flask, there is no bung there. So that is also a mistake. One is the method of collection is wrong, and another one is the conical flask does not have a bung. Then suggest one reason why the gas produced in a flask is passed through concentrated sulfuric acid. Concentrated sulfuric acid is a drying agent. It is used to remove the moisture from the gas. So it's a drying agent to remove the water or use as a drying agent. Suggest why this experiment is done in a fume cupboard. Fume cupboard experiments, whenever a question is there, why experiment is done in a fume cupboard? Usually the gases which are given off, the toxic gases are given off. That's why the experiment should be done in a poisonous or a toxic gas is released. So it should always be done in a fume cupboard, or properly ventilated room should be used. Then planning experiments are there. I sort out the experiments, some common experiment. First one, methods of purification. You can go through this. These methods of purification experiments are there. The common experiments I sorted out. Then energy from chemicals like exothermic, endothermic reactions. Then rate of a reaction, how you can show that measure a rate of reaction or show substance is a catalyst. Then acid, alkali, and salt preparation and the reactions are there, how it can be done. And then metal and extraction, like comparing the reactivity of different metal based on different scenarios, like sometime reacting with acid, sometime reacting with different salt solutions. Flame colors you have to learn, even it will be there, the qualitative analysis. So this was about paper 6. Any question or doubt related to the class today?
No, sir.
So go through this file and classified paper 6 already I shared with you. I have shared with you, and recording is there. The solution videos are there. You can go through that in case if part you're not able to understand.